It's not the year 2050, and this isn't a scene from a sci-fi film. Right now, in mid-2025, one nation has been quietly building the future, not through promises, but through products. Commercial flying cars, robots running marathons, AI chips 30% cheaper than Nvidia's, and quantum computers powering the world's first secure international communication network. While much of the West is still debating ethics or perfecting AI in labs, China already has millions riding in driverless taxis, using homegrown operating systems independent of Android, and testing non-invasive brain-computer interfaces. The question is no longer, can they do it? It's whether the rest of the world is ready to live in this new reality. This is not about pledges, but about devices, data, and business models already deployed. From robotics, AI, and quantum computing to clean energy, signs are emerging that the global tech map could be redrawn, not through summits, but through code. Right now, in mid-2025, one nation has been quietly building the future, not through promises, but through products. Commercial flying cars, robots running marathons, AI chips 30% cheaper than Nvidia's, and quantum computers powering the world's first secure international communication network. While much of the West is still debating ethics or perfecting AI in labs, China already has millions riding in driverless taxis, using homegrown operating systems independent of Android, and testing non-invasive brain-computer interfaces. The question is no longer can they do it. It's whether the rest of the world is ready to live in this new reality. This is not about pledges, but about devices, data, and business models already deployed. From robotics, AI, and quantum computing to clean energy, signs are emerging that the global tech map could be redrawn, not through summits, but through code. Join Top 10 Discoveries Official as we explore 8 technology frontiers where China is reshaping the global game. First, multidimensional transportation. Imagine booking a ride on an app, and minutes later, a pilotless flying taxi lifts off to collect you. No noisy propellers, no traffic jams, no emissions. This is no longer fiction. In 2025, the EHang 216S, an electric vertical takeoff and landing aircraft built in China, entered commercial service in Guangzhou and Hefei after completing over 10,000 passenger test flights. Each flight lasts around 21 minutes, reaching speeds up to 80 miles per hour, about 130 kilometers per hour, and covering a range of roughly 19 miles, or 30 kilometers. Charging currently takes 2 hours, though fast charge technology is in development. 10-minute charging is still a goal, not yet reality. EHang has already secured orders from at least 7 countries, totaling more than 1,200 units, including Malaysia, Indonesia, Japan, and several European buyers. While claims of sales to 18 countries remain unverified, the technology's international reach is undeniable. Meanwhile, on the ground, another transport revolution is taking shape. China has approved full-scale driverless taxi operations in major cities like Shenzhen, Beijing, and Wuhan. Led by Baidu's Apollo and WeRide, these robo-taxi fleets have completed over 7 million rides, far surpassing U.S. programs, where Waymo logged roughly 250,000 weekly trips by April 2025. What's fueling this boom? Fares are about 3 times cheaper than traditional taxis, and notably, there have been no serious accidents across more than 20 million miles of operation. Through electric VTOLs, China is turning flying taxis into a real industrial product, pulling ahead of Western nations still bogged down by safety regulations. With Robotaxis, it's optimized the commercial model instead of stopping at tech demos, laying the groundwork for a fully driverless urban future. From road to sky, China is constructing a 3-dimensional transportation ecosystem, merging data, AI, and electrification into a seamless, affordable, low-emission mobility network. It's the beginning of a world where smart neighborhoods expand vertically into the skies. Second, humanoid robotics. While, many countries still treat humanoid robots as trade show curiosities, China has moved them onto real production lines. In 2025, the Unitree G1, a compact humanoid robot, became a social media hit, not just for its dance moves, but for its $16,000 price tag. Compared to Boston Dynamics' $75,000 Spot, the G1 is nearly 5 times cheaper, putting robotics, once the domain of elite labs, within reach of small businesses, universities, and independent developers. This isn't just a new product, it's a signal of a new wave in affordable commercial robotics. Consider BYD, China's largest electric vehicle manufacturer. At its Hefei plant, 97% of production processes are automated, with over 1,200 welding and assembly robots installing 4 tires in just 48 seconds. With nearly 1 million employees, BYD is targeting 500 robots per 10,000 workers by 2025, around 50,000 robots system-wide. Industry observers believe it's already reached that goal, driven by heavy investment, rapid scaling, and its own in-house humanoid robotics programs. This represents a rare mix of large-scale, low-cost automation and real-world application, helping China close the gap with global robotics leaders not by chasing the highest-end prototypes, but by democratizing practical automation. In factories like BYD's, robots don't just weld or assemble, they learn and adapt. Here, AI, smart manufacturing, and humanoid robotics converge to form the next generation of industrial ecosystems, where every worker is paired with a silicon counterpart. Third, Made in China AI. The year 2025 marks a surprising leap for Chinese artificial intelligence, not through chatbots, but through a complete AI stack connecting chips, algorithms, labs, and products. Take DeepSeek R1, a mathematical reasoning model with 671 billion parameters. In tests like AIME and Math 500, it scores around 80%, nearly on par with top US Olympiad students. What's impressive isn't just accuracy, but efficiency. It uses a mixture of expert system that activates only 37 billion parameters per query, cutting costs by up to 95% compared to similar-sized Western models. That means a massive model still accessible from a gaming PC via a compressed version. Enter QW30B, an affordable 32 billion parameter AI that runs on consumer GPUs like the RTX 4090 at a cost of roughly 20 cents per million requests. Its performance often matches DeepSeek R1 on math benchmarks, proving bigger isn't always better. China is prioritizing efficiency over scale. Behind these models lies Ascend 9N10B, Huawei's 7-nanometer AI chip, produced by SMIC. Reports suggest it approaches Nvidia's H100 in performance, though with lower yields, around 20 to 30%. Despite that, its existence amid export bans, EUV shortages, and EDA restrictions is a milestone in self-reliance. DeepSeek, QW30B, and Ascend 910B together represent coordination across models, software, and hardware, a nearly independent AI supply chain. China isn't just building its version of ChatGPT. It's rewriting the AI production model, from chips to cloud, devices to training. And if these systems keep outperforming Western ones on price and accessibility, the next AI app you use might not come from Silicon Valley, but from Shenzhen. Fourth, brain-machine interfaces and biotech. If brainwave-based communication still sounds like science fiction, think again. In China, it's leaving the lab. BrainTalker, developed by Tianjin University and China Electronics Corporation in 2019, is a specialized chip that helps brain-computer interfaces decode brainwaves faster, more accurately, and with less power. Its mission enables stroke or paralysis patients to communicate through thought alone. No surgery, no physical movement. One day typing might be obsolete. We'll just think, and computers will understand. However, claims of 50 words per minute without implants remain unverified. Current non-invasive EEG systems average 10 to 12 words per minute. Higher speeds, 70 to 80 words, typically require surgical electrodes, as seen in Stanford studies. If BrainTalker truly achieves that performance non-invasively, it would mark a global breakthrough. Some reports suggest it's 100 times more efficient and uses 1,000 times less power than early analog BCI systems, though results depend on comparison standards. Regardless, the direction is clear. China wants to make BCI rehabilitation accessible, safe, and affordable. Similar systems like the US IPSI hand allow patients to control prosthetics through thought. But BrainTalker aims to do so at a fraction of the cost, with fewer external components. If progress continues, high-performance, low-cost BCI devices could become a new international standard for medical recovery, and perhaps for everyday computing. It's a thrilling and slightly unsettling vision. A future where keyboards, mice, and touchscreens give way to pure thought. Imagine a future where emails are sent by thought, navigation is guided by intuition, and people with paralysis communicate naturally. No hands, no voice, just the mind. That's not 2050. It could arrive by 2030 if technologies like BrainTalker reach maturity. If artificial intelligence is the brain of the new digital era, then quantum computing is the reflex, and quantum secure communication is the nervous system that connects it all. China is investing heavily in all three. The Zhuchangji 3.0, a 105-qubit superconducting quantum computer built by the University of Science and Technology of China, has already demonstrated staggering performance. In one experiment using an 83-qubit random circuit, it completed a computation in just a few hundred seconds, something that would take the world's most powerful classical supercomputer, Frontier, over 6 billion years to finish. That's roughly 1 quadrillion times faster. Even compared to Google's latest systems, such as Willow, Zhuchangji 3.0 performs over 1 million times faster on similar tasks. But this isn't only about speed. China is closing in on what's called quantum advantage, the point where quantum machines move from laboratory curiosities to practical tools. Meanwhile, reports suggest the existence of an encrypted intercontinental communication system known as MADSA, combining a 3,000-mile terrestrial fiber network with satellite links. Though not officially confirmed, its design mirrors ultra-secure systems used by global banks and governments. Imagine a data highway where information flows at near-light speed, shielded from interception, connecting cities from Beijing to Dubai, Shanghai to Frankfurt. The logic behind pairing quantum computing with quantum communication is simple. Speed plus security equals control. With Zhuchangji 3.0, China approaches the ability to tackle problems no supercomputer can. With a network like MADSA, it could transmit sensitive information across continents without fear of interception. Together, these technologies form the foundation for a new kind of digital infrastructure, one where finance, defense, healthcare, and governance rely on computing power that's both extreme and unhackable. While terms like quantum encryption or intercontinental data links once sounded like tech conference jargon, they're now tied to real systems operating in the field, backed by state-level funding. Meanwhile, in the deserts of China, another quiet revolution is underway, one focused on energy. While most nations race to expand solar and wind, China has revived an almost forgotten technology, thorium-based nuclear power using molten salt reactors. The TMSR LF1 reactor, located deep in the Gobi Desert, may only produce 2 megawatts of power, but its significance lies elsewhere. It doesn't need water for cooling. Instead, it uses air, ideal for arid environments. This reverses traditional energy logic. Instead of building power plants near rivers or seas, China is bringing power generation to the desert. Thorium, unlike uranium, is far more abundant in the Earth's crust and much harder to weaponize, making it safer and less politically sensitive. It also produces waste that remains radioactive for only a few hundred years instead of tens of thousands, reducing long-term storage and safety burdens. In short, thorium isn't just a technical innovation. It's a political and environmental opportunity. By 2029, China plans to scale up with a 10-megawatt electric, 60-megawatt thermal thorium reactor, capable of powering tens of thousands of homes. Looking ahead to 2035, with a national goal of reaching 200 gigawatts of nuclear capacity, China could deploy dozens of small to mid-sized thorium plants across cities, deserts, and remote regions. If successful, this could redefine nuclear power, from massive water-cooled installations to compact, flexible units that operate safely almost anywhere. The West pioneered molten salt technology in the 1960s but never commercialized it. While others debate, China is quietly building. If these projects scale, clean, safe, and decentralized nuclear energy could become a reality within a decade. And as the energy grid evolves, the data grid is following fast. Enter 6G and the Internet of Things, a network designed not just to connect devices, but to merge physical and digital life. Imagine a world where mobile signals link your body to your doctor in real time, or where a surgeon in Beijing operates instruments in a Shanghai hospital with almost no delay. That's the promise of 6G. Speeds up to 100 gigabits per second and latency under 1 microsecond, more than 100 times faster than human reflexes. While no 6G-powered surgeries have been documented yet, China's 5G networks already enabled a remote brain operation over 3,000 kilometers back in 2019. With 6G's 2,000 times lower latency, real-time remote medicine, autonomous factories, and borderless education all become possible. China has already launched large-scale 6G trials in cities like Beijing and Shanghai, with companies like Huawei, ZTE, China Mobile, Ericsson, and Nokia Shanghai Bell participating. Hundreds of patents and dozens of test zones have been registered. If 5G built the foundation for smart cities, 6G could become their brain, an invisible nervous system connecting every car, traffic light, drone, and device. In the 6G era, networks won't just transmit data, they'll transmit decisions. Finally, there's biomanufacturing and synthetic agriculture, a frontier that's transforming carbon into life itself. Picture a factory without chimneys or steel, filled instead with engineered bacteria that consume CO2 and produce protein. It's happening already. China and other nations are investing heavily in aerial agriculture, where microorganisms turn captured carbon into food and fuel. Some projects claim production rates of around 5,000 tons per year. Enough to prove feasibility but still short of industrial needs, since feeding 1 million pigs would require over 67,000 tons. It's the early stage of a revolution, but the direction is clear. Carbon is no longer just waste, it's a resource. At the same time, synthetic biology is entering medicine. In Texas, researchers are designing bacteria to seek and destroy cancer cells at a projected cost of just $1 per dose. Tens of thousands of times cheaper than today's treatments. Though still in trials, the implications are staggering programmable microbes as living, targeted therapies. China now accounts for about 24% of the global pharmaceutical supply chain, particularly in generics and antibiotics. This dominance isn't just economic, it's geopolitical. Whoever controls the medicine supply controls trust. Step back and a pattern emerges. While others debate, China builds, from AI and chips to quantum links, thorium power, 6G networks, and biotechnology. Not everything will succeed, but each external restriction seems to drive greater self-reliance. Bit by bit, an independent tech ecosystem is taking shape, not to isolate from the world, but to ensure resilience when global systems fracture. Because in the end, the true measure of progress isn't speed, it's depth. The nations shaping tomorrow aren't the ones chasing headlines, but those investing steadily, strategically, and from the ground up. So here's the question. In a world of rapid change, what long-term ecosystem strategy should a nation pursue to secure its future?